So I'm just going to read for a while the Lua reference manual and have a look at it. See, it's got the MIT license and compatible with GPL. You know, I'm not doing this for any money. I do believe that they have a reference manual that you can get online. I'll try and link all this stuff, and that you should help support their project. All right, Lua 5. I'll link all this stuff under the video. Copyright is 2006-2012 anyway. Lua 5.1 reference manual. Oh, and I'll link the Jazz YouTube that I'm listening to while reading this under the video as well. Lua 5.1 reference manual by Robert Larusalimsky, Luis Enrique de Figueiredo, Waldemar Sellers. I'm not sure how to pronounce those. I apologize. Introduction. Lua is an extension programming language designed to support general procedural programming with data description facilities. It also offers good support for object-oriented programming, functional programming, and data-driven programming. Lua is intended to be used as a powerful, lightweight scripting language for any program that needs one. Lua is implemented as a library, written in Clean C. That is the common subset of ANSI C and C++. Being an extension language, Lua has no notion of a main program. It only works embedded in a host client, called the embedding program or simply the host. This host program can invoke functions to execute a piece of Lua code, can write and read Lua variables, and can register C functions to be called by Lua code. Through the use of C functions, Lua can be augmented to cope with a wide range of different domains, thus creating customized programming languages sharing a syntactical framework. The Lua distribution includes a sample host program called Lua, which uses the Lua library to offer a complete standalone Lua interpreter. Lua is free software and is provided as usual with no guarantees, as stated in its license. The implementation described in this manual is available at Lua's official website, www.lua.org. Like any other reference manual, this document is dry in places. For a discussion of the decisions behind the design of Lua, see the technical papers available at Lua's website. For a detailed introduction to programming in Lua, see Roberto's book, Programming in Lua, 2nd edition. 2. The language. This section describes the lexis, the syntax, and the semantics of Lua. In other words, this section describes which tokens are valid, how they can be combined, and what their combinations mean. The language constructs will be explained using the usual extended BNF notation, in which bracket A means 0 or more A's, and square bracket, okay, so curly braces A means 0 or more A's, and square bracket A means an optional A. Non-terminals are shown like non-terminal. Keywords are shown like K-word. and other terminal symbols are shown like quotes with equals inside. The complete syntax of Lua can be found in Section 8 at the end of this manual. (2.1) Lexical conventions. Names, also called identifiers in Lua, can be any string of letters, digits, and underscores, not beginning with a digit. This coincides with the definition of names in most languages. The definition of letter depends on the current locale. Any character considered alphabetic by the current locale can be used in an identifier. Identifiers are used to name variables and table fields. The following keywords are reserved and cannot be used as names: and, in, repeat; break, false, local, return; do, for, nil, then; else, function, not, true; else if, or until, while. Lua is a case-sensitive language and is a reserved word, but and, capital A, lowercase nd, and, capital A, capital N, capital D, are two different valid names. As a convention, names starting with an underscore followed by uppercase letters, such as underscore, version, are reserved for internal global variables used by Lua. The following strings denote other tokens: plus, minus, asterisk, /%, what is it called? The caret, hash, equal, tilde equal, less than equal, greater than equal, less than, greater than, equal. Left parentheses, right parentheses, left curly braces, right curly braces, left square braces, right square braces. Semicolon, colon, comma, period, period, and period. Literal strings can be delimited by matching single or double quotes and can contain the following C-like escape sequences, like /A, so in parentheses bell, and /B, parentheses backspace, /F, that's form feed, /N, new line, /R, carriage return, /T, horizontal tab, /V, vertical tab, backslash is backslash. A backslash, then a quote, quotation mark, double quote, and backslash with the apostrophe, single quote. Moreover, a backslash followed by a real new line results in a new line in the string. A character in a string can also be specified by its numerical value using the escape sequence, /DDD, where DDD is a sequence of up to 3 decimal digits. Note that if a numerical escape is to be followed by a digit, it must be expressed using exactly 3 digits. Strings in Lua can contain any 8-bit value, including embedded zeros, which can be specified as /0. Literal strings can also be defined using a long format enclosed by long brackets. we define an opening long bracket of level n as an opening square bracket followed by n equal signs, followed by another opening square bracket. So, an opening long bracket of level 0 is written as bracket bracket. An opening long bracket of level 1 is written as left bracket equals left bracket, and so on. A closing long bracket is defined similarly. For instance, a closing long bracket of level 4 is written as right bracket equal right bracket. A long string starts with an opening long bracket of any level and ends at the first closing long bracket of the same level. Literals in this bracketed form can run for several lines. Do not interpret any escape sequences. Ignore long brackets of any other level. Ignore long brackets of any other level. They can contain anything except a closing bracket or the proper level. For convenience, when the opening long bracket is immediately followed by a new line, the new line is not included in the string. As an example, in a system using ASCII, in which A is coded as 97, new line is coded as 10. And I guess that's a 1 or an L, is coded as 49. I think that's a 1. The 5 literal strings below denote the same string. A equals apostrophe ALO backslash N123 quote apostrophe. A equals quote ALO backslash N123 backslash quote. A equals apostrophe backslash 97LO backslash 10 backslash 04923 quote apostrophe. A equals left bracket ALO. Then spaces return 123 quote close bracket. A space equals space left bracket equals left bracket return ALO return 123 quote right bracket equal right bracket. I see. So he had said the opening long bracket's immediately followed by a new line. The new line's not included in the string. Okay. So all those things that I read supposedly denote the same string. A numerical constant can be written with an optional decimal part and an optional decimal exponent. Lua also accepts integer hexadecimal constants by prefixing them with 0x. Examples of valid numerical constants are 3, 3.0, 3.1416, 314.16E-2, 0.31416E1, 0xFF, 0x56. A comment starts with a double hyphen. It's parentheses, dash, dash, close parentheses. So 2 dashes are a comment. Anywhere outside a string. If the text immediately after dash dash is not an opening long bracket, the comment is a short comment, which runs until the end of the line. Otherwise, it is a long comment which runs until the corresponding closing long bracket. Long comments are frequently used to disable code temporarily. 2.2 Values and Types. Lua is a dynamically typed language. This means that variables do not have types. Only values do. There are no type definitions in the language. All values carry their own type. All values in Lua are first-class values. This means that all values can be stored in variables, passed as arguments to other functions, and returned as results. There are 8 basic types in Lua: nil, Boolean, number, string, function, user data, thread, and table. Nil is the type of the value nil, whose main property is to be different from any other value. It usually represents the absence of a useful value. Boolean is the type of the values false and true. Both nil and false make a condition false. Any other value makes it true. Number represents real, double precision floating point numbers. It is easy to build Lua interpreters that use other internal representations for numbers, such as single precision float or long integers. See file luaconf.h, luaconf.h. String represents arrays of characters. Lua is 8-bit clean. Strings can contain any 8-bit character, including embedded zeros, like /0. See section 2.1. Lua can call and manipulate functions written in Lua and functions written in C. The type user data is provided to allow arbitrary C data to be stored in Lua variables. This type corresponds to a block of raw memory and has no predefined operations in Lua, except assignment and identity test. However, by using metatables, the programmer can define operations for user data values. See section 2.8. User data values cannot be created or modified in Lua, only through the C API. This guarantees the integrity of data owned by the host program. The type thread represents independent threads of execution, and it is used to implement coroutines. See section 2.11. Do not confuse Lua threads with operating system threads. Lua supports coroutines on all systems, even those that do not support threads. The type table implements associative arrays. That is, arrays that can be indexed not only with numbers, but with any value, except nil. Tables can be heterogeneous. That is, they can contain values of all types, except nil. Tables are the sole data structuring mechanism in Lua. They can be used to represent ordinary arrays, symbol tables, sets, records, graphs, trees, etc. To represent records, Lua uses the field name as an index. The language supports this representation by providing a.name as syntactic sugar for a bracket quote name quote close bracket. A.name. There are several convenient ways to create tables in Lua. Like indices, the value of a table field can be of any type, except nil. In particular, because functions are first-class values, table fields can contain functions. Thus, tables can also carry methods. See section 2.5.9. Tables, functions, threads, and full user data values are objects. Variables do not actually contain these values, only references to them. Assignment, parameter passing, and function returns always manipulate references to such values. These operations do not imply any kind of copy. The library function type returns a string describing the type of a given value. 2.2.1 Coercion. Lua provides automatic conversion between string and number values at runtime. Between string and number values. Any arithmetic operation applied to a string tries to convert this string to a number, following the usual conversion rules. Conversely, whenever a number is used where a string is expected, the number is converted to a string. In a reasonable format, for complete control over how numbers are converted to strings, use the format function from the string library. See string.format.